All right, let's keep going. I think we're on number 12. So wants to know what the weight of the block in newtons is. So in this equation, we're going to be doing force equals mass times acceleration. And the mass is 0.22 kilograms. And the acceleration due to gravity is 9.8 meters per second squared. And that you're going to have to know. The acceleration due to gravity on Earth at sea level is 9.8 meters per second squared. And then when you do the math on that, oh, I see. One thing I did forget is that it's given to you in 220 grams. So you're going to have to convert the 220 grams into kilograms so you can get this in newtons. So I'm just going to do a dimensional analysis way here. And so there's 1,000 grams in 1 kilogram. And so when grams cancel, so 220 divided by 1,000 is 0.22 kilograms. And then you can multiply them together. The reason why you have to do that is because you need your answer in newtons, and a newton is a kilogram times a meter per second squared. So when you multiply those together, you're going to get your answer, and it's going to be in newtons, which is the same thing as a kilogram times meter per second squared. All right, so for number 13, same equation, force equals mass times acceleration. And we're going to have, this one's on Mars. So the acceleration due to gravity is going to be different. And so our mass stays the same. So 0.22 kilograms. And we're going to multiply that by the acceleration due to gravity on Mars. And it tells you that that's 3.8 meters per second squared. And that you will not need to memorize, although not bad to know that, acceleration due to gravity on Mars. And when you do the math on that one, you'll also end up in newtons. A kilogram times meter per second squared is a newton. Number 14 is another force equals mass times acceleration problem. The mass is 2020 kilograms times 32 meters per second squared. So when you solve that one, you're going to get your answer in newtons. All right, I think we're on 15. And 15 is kind of a strange one because it's got lots of information. But really, the thing you have to realize is that basically team one is going to win. And the reason why team one is going to win is because they pull with more force. They're pulling with 5,000 newtons worth of force, and that's greater than the other team, which is pulling with 4,500 newtons worth of force. So team one will be the winner. All right, number 16 is a power problem. So we're going to be power equals work divided by time. And in this case, we did 50,000 joules of work, and we did that over 8 seconds. So we're going to end up with our answer. It's going to be around 6,250. Now, the units on this is joules per second. And just so you know, a joule per second is also known as a watt, which is the unit that you've memorized is the unit of power. So watt is the same thing as a joule per second. On number 17, we're going to convert. And so in that case, you're going to want to use the metric stair step. You're going to need to have that memorized. King Henry died by drinking chocolate milk. All right. And that'll make things easier for you. You're going to convert 25 millimeters to meters. So you do the steps up and down. And remember, if you move left, move the decimal left. If you move right, move the decimal right. So that's 17, 18, 19. Number 20, I do want to go over a dimensional analysis problem. We have 135 meters per second, and we need to convert that into miles per hour. So we're going to write it 135 meters over seconds, and the conversion is there for you, and there's 1,609.34 meters in 1 mile. And we need to get, there's 3,600 seconds in 1 hour. So in this case, meters is on top, meters is on bottom, so they're going to cancel. Seconds is on bottom, seconds is on top. And then you're going to multiply by everything on top and then divide by everything on bottom. And your units are going to be left in miles per hour. Now we need to go another dimensional analysis problem. So 23 liters into gallons. So we write down what's given, 23 liters, and our thinking line, and that we need liters to cancel. In 1 liter, there is 0.264 gallons. Liters cancel. And so when you do the 23 times that is going to give you 6.072 gallons. There's your answer to that. And then finally calculate the volume of a cylinder with a diameter of 45 centimeters and a height of 56. So we're going to use our equation pi r squared h, and that's to find the area of a cylinder. Pi is 3.14. Our radius is going to be half our diameter. So 22.5 centimeters. We need to square that. And our height is 56 centimeters. So now if we look at our units, we get a centimeter times a centimeter, which gives me a centimeter squared times a centimeter is a centimeter cubed. And that is a volumetric measurement. Now remember, you need to take 22.5 times 22.5 first, because the order of operations, you need to square it first. Then multiply by pi and 56 centimeters, and you're going to get 89,019 centimeters cubed.